This is Dr. Sridhar back to you with another video session on types of control systems. And in this video session, I'm going to discuss about what are the various classifications and how we are going to divide or how we are going to classify the control systems into various types. Now, in this video session, first let us start with this classification with open loop control systems and closed loop control systems. Now, these open loop and closed loop control systems, we are going to classify the control systems into these two categories based on the feedback. If the feedback is connected, then that becomes closed loop control system. If the feedback is absent in the system, then that system will be a open loop control system. So, if based on the presence of the feedback, the control systems has been classified into two categories. One is the open loop control system and next one is the closed loop control systems. And in today's video session, I am going to present with various examples and advantages, merits and demerits and disadvantages of these two types of control systems. So what is this open loop control system? This open loop control system is just control is blind. So there is no control action and this system will not have any control over the output. Once if the input is given to the system will process the input and the system will present some output at the output terminals. That's all. Now there is no control over the output. So this is what open loop control system is. In an open loop control system, this open loop control system utilizes an actuating device to control the process directly without using feedback. So there is no such feedback from the output to input. So this feedback is highly helpful for us to improve the accuracy of the system. So such feedback is completely not there in the open loop systems. So what are the advantages of this configuration, and if the feedback is connected to the system, what happens to the control system and what it will be, and what are the other merits and demerits, that's we are going to discuss now. So this is, see here in this simple example, input if it is given to a controller or amplifier. Now this will be processed further and it will be given to a plant, or which is nothing but the process dynamics, and finally you can see the output. So here input is given to a system, and if controller is connected, the controller will adjust the input signal such that how much of input the plant is required, a plant or process is required. So that will be directly sent to the output terminals here. So input and output, and remaining thing is nothing but there will be a system or control system. So input if it is acting on the control system, you can get some output. Here there is no corrective measure. Now suppose if you want to correct the output as per the required, as per the desired amount, now we cannot do it. Just simply if you are giving input, now based on the experience, you can suggest one controller here, or which controller is nothing but it could be an amplifier. Now this amplifier or controller will adjust the input such that how much of input is required for the plant or process. The process will process the input and it will present at the output terminals. So this is what an open loop control system is. Now coming back to the closed loop control system. In the closed loop control system, control takes account of actual output and compares this to the desired output. So there will be a corrective measure. Now always this actual output, which is the output of the process plant, that will be measured with the desired signal. So it is a continuous process. So how can we do that? By connecting a feedback loop from the output to the input, this correction can be achieved. So with the help of this particular feedback, now continuously we can assess and we can monitor whether this actual output is equivalent to desired output or not. So in this one, a closed loop control system uses a measurement of the output and feedback of this signal to compare it with the desired input, that is nothing but reference or command, which is nothing but desired value. So desired input is nothing but actually that's what I am expecting from the whole system. Now how this feedback it will be connected and where this comparison could be done in the control system means, now let us examine this block diagram representation. Here this is a desired output. The desired output is nothing but that is my actual intention of establishing this whole control system, that will be there as an input for the whole system. And then measurement unit is nothing but this is the feedback unit. This is completely, it is a feedback unit. this will be excited by taking or by tapping the actual output. This is nothing but the output is nothing but this is the actual output. This will be tapped and it will be given to the measurement, and this is the summer point here. This is the comparator. It will continuously compares what is the actual output and whatever the desired output. The resultant, well, the difference between these two, it will be the net input for the whole plant. Now plant is nothing but it is a combination of controller as well as the process unit. So this is the mechanism. This will be takes place in the closed loop control system. In the closed loop control system, always now we can assess or we can measure what could be the actual difference between the desired value and the actual value. So that can be achieved with the feedback loop. That feedback loop is established between output to input. This is this unit is this path is nothing but it is a forward path. So forward path is nothing but always it travels from input to output. So only in one direction. In the reverse direction through this one, this is nothing but this is a feedback path. So this value is nothing but it is a feedback path and this is a forward path. So like this, there is a small difference is there between the open loop control system and closed loop control system. In the open loop control system, you cannot find this feedback path, but in the closed loop control system, feedback only very important here. So what are the, how can we design this control system? Now if you could see, now there will be a controlling action. Now where I am going to continuously monitor whether this control has been provided to the, has been reached the desired value or not. And again, this can be achieved with respect to actuators. And actuators means now sometimes this could be given to the mechanical systems or electrical systems, whatever it may be. But ultimately, what is our intention is very important here. And mechanical system and the output of this mechanical system will also decided by the environment, in which environment this was connected. And again, the deviations could be measured with respect to the sensors. And now the output of the sensors is nothing but a signal that could be captured. And finally, the signal only tells whether you reached as per the expectations or not. So the linkage between the various stages are nothing but the controlling action. So what parameter you want to control, like that you have to give the signal to the actuators. Then actuators will respond and they will give a command to the mechanical system to act. And then again, this mechanical system is also environmentally, there could be a difference and that will also be monitored here. Then the resultant deviations will be sensed by the sensors, and finally the sensors output is given to the signal. It means the output or the performance of the sensors could be analyzed by capturing the signal with the help of signal capture unit. And finally, now there could be a comparison between whether control has been achieved properly or not. So again, so what is the desired system performance? Now from where you are going to assess? Now from the controlling mechanism, you can ensure whether the performance of the system is as per the expectations or not. And what are the various other parameters will influence in the control system? Now there could be some disturbance. Now I have taken the mechanical system here. Similarly, we can take the electrical system or any other system physically existing on the earth. But for better understanding, I have taken the mechanical system here. So mechanical system majorly more prone to the disturbances like mechanical disturbances, or sometimes what happens, it may be vibrated on itself, or it may act unnecessarily with respect to the unnecessary disturbances occurs in and around the system. Those are nothing but comes to the disturbances. So these disturbances are very dominant if the system is very sensitive to the disturbances. And one more thing is nothing but while you are capturing the signals, there could be a noise. So the capturing of the signal could be done with respect to or with the help of signal capturing devices like CROs or some storage devices. Now in that one, what happens sometimes by connecting the probes to the CROs or kind of things, so definitely unnecessarily there we might have inserted some noise into the system. That noise also plays a vital role while capturing the signal. So these are the different disturbances we can see in the system. So finally what happens, the control whether you reached as per the expectations or desired output, that will be measured at the controlling block. That is nothing but the desired system performance. It could be analyzed at the control point. Now coming to the open loop control systems and closed loop control system, what are the key points we have to remember and where the disturbances will take place and what type of disturbances and what are the various blocks called in the open loop and closed loop control systems means now the output signal of open loop control system is not fed back to influence the controlling action. The controlling action of an open loop control system depends only on the input signal. Just how much of input we are giving to the system, that only decides the output. Now there is no controlling or there is no comparison between whether the output is reached the desired value or not. That mechanism is completely absent in this open loop control system. So whatever the input we are giving to the system, that only plays a key role in deciding the output. Output is directly, it depends on the input and the system. So open loop control systems are not capable of filtering disturbances. So here the disturbance, suppose some sort of disturbance has been taken place. Now how can we ensure what type of disturbance it has taken place and at what point in the system the disturbance has been taken place? We don't have any correction measure. Now the disturbance will also act like an input, and in addition to the actual input, and disturbance will also act like a input on the system, especially at the plant. Now these two disturbances, this disturbance and the actual input, both will act like a input on the system, and the resultant will be the combination of disturbance signal and the actual input that will appear at the output terminals. Not only disturbances, sometimes noises also, some glitches kind of thing also plays vital role. So whether it is disturbance or not, now at some instance, some cases what happens, we cannot differentiate which one is disturbance and which one is actual signal. So actually, if you are taking any signal here, now suppose, let me assume this is the process or plant. Now this is the input I have chosen carefully in order to adjust the output. So suppose if input is given to this particular plant and output is here. Now suppose, let me take this plant is nothing but it is just like a potential divider or transformer kind of thing. Here I am giving 100 volts is the input. Now I want to see 5 volts is the output. Let me assume this input and output and plant can be represented by suitable electrical system. Let me take this example for better understanding. So what is my intention? I want to develop 5 volts as the output. This is the desired value. Now how can we achieve? Suppose if you have 100 volts, then 100 volts to be brought to 5 volts level. So what is the device? This is nothing but this is our plant. This is completely, what is the plant here? So this is my plant. So this is the process, or this is nothing but the plant. So this is the input and this value is nothing but the output, and this is nothing but it is a plant. Now see, input I have selected 100 volts in order to achieve the 5 volts. Now if this system, if this whole system is operated at higher temperatures, if it is operated at higher temperatures. Now if it is higher temperature, what happens? Now this resistance of this inductive coil may not be constant, it will vary. So it may be decreased or increased based on the temperature. So what I want to convey you is, now this system or this particular plant is sensitive to the environmental variations, or it also depends on some type of environmental changes. So that temperature could be seen as a disturbance. This is unnecessarily we are expecting because of the environmental variation. So this could be a disturbance, or it is nothing but it could be a noise. Noise is nothing but not an exact word here, but more or less disturbance, noise, these are nothing but which are not intentionally we require. So not the required signals, those are nothing but the disturbances. Now how can we differentiate in the electronics and electrical systems means these noises and disturbances will have different frequency levels. Now if the operated frequency is 50 Hz, this noise frequency and disturbance frequency maybe other than the 50 Hz, such frequencies signals are called as noises or unwanted signals. Those are the disturbances. Here in this example, this temperature variation could be seen as a disturbance because unnecessarily I am not expecting this and I don't want to see the temperature variations here. Only my intention is if the 100 volt is given to the plant, now that output could be 5 volts. That is my intention. 100 volt will be a input and 5 volt is nothing but it is a output. So in order to achieve this level of voltages or 100 volt to 5 volts, I have chosen a plant. Now this plant I am expecting to give 100 volt to 5 volts. Right. This is the input and this is the output. Now, if this input is given to the plant will act, and based on the number of turns or whatever it may be. Now, I am not interested here how we are going to achieve 5 volts. It was assumed that if 100 volt is given to this type of plant, this plant may consist of 100 tons or 50 tons immaterial here. Now, we have assumed that this plant is capable to produce 5 volts output. So, 100 volt can be transformed or can be reduced to 5 volts if the 100 volt is given to this particular plant. That is our intention here. Now, if this same plant, if it is kept at higher temperature, what happens? We may reach 5 volts or we may not reach 5 volts. Means, indirectly, this particular plant on this one is nothing but it is input is nothing but it is a temperature variations, and next one is nothing but 100 volt is the signal. So, finally, this 5 volts. Now, whether we are going to reach this 5 volts or not, now this will be decided by the inputs, two inputs, 100 volts and temperature. So, if now this temperature will also a input, now means once this temperature is, if the temperature is deviated or if the temperature is varying, then the temperature could be seen as a input by the plant. Now, plant will observe two inputs. One is the actual input 100 volts and another input is nothing but the temperature variation. Not only temperature, other environmental variations. All these environmental variations, this plant will see them as a input only. Of course, those inputs are unwanted inputs. But anyhow, in the practical system, such type of inputs always it will be there. So, along with this actual input, you have to analyze how many number of inputs it will act. So, all these inputs, 100 volts and other disturbances will influence the output. So, because of that only, of course, in the ideal system, 100 volts, if it is given, 5 volts we are going to get. But in the practical case, that will not possible. Why? Because in addition to this 100 volts, another temperature, another disturbances will also act as an input to the plant. So, because of this so many inputs, this output may not be reached or output may not be attained. So, that is the reason here. So, with these two simple examples, we can say that open loop control system won't have any control on the disturbances, or we cannot eliminate this disturbances and or noises from the system. That's what open loop control systems are not capable of filtering disturbances or noise. Open loop control systems are also suitable when input signal for satisfactory system performance can be estimated or approximated and does not change. So, what are the advantages of this open loop control systems? Means these open loop control systems are that its structure is very simple as compared to the other loop control system, which is nothing but the closed loop control system, and it is very cheap to build. Now, the construction, no more complexities are there. Only one input, one process. Along with the process, one controller will be there. Controller, process, and the input signal. So, these are the major blocks. Now, construction is very simple. Building the open loop control system is nothing but very cheaper also. So, and it is very simple as well. And suppose if you could observe this block diagram representation here, input, that is nothing but the actually desired value, reference value. Now, input could be, now suppose, what is the transducer here? Transducer is nothing but it is a conversion unit. It will transform or it will change the energy from one form to the another form. Suppose if the form of energy is not, suppose if you could see electrical machines like generator or motor, what happens? Motor is nothing but it is a device which converts electrical energy to the mechanical energy. So, motor could be a transducer also. So, if the input is not in the actual form, so let us assume this transducer converts all other energies into electrical energy. Let us assume if it is if we want to control the electrical parameter, so we require only electrical parameter. Now, if the input is nothing but the displacement, let us assume displacement. So, distance or displacement. This distance or displacement should be converted to the electrical signal. So, in this process, we require a transducer. Let us assume that this transducer is capable to convert mechanical energy to the electrical energy. So, that electrical output is given to the controller. Here, this controller will compare the disturbance. Means here, actually, this disturbance cannot be compared. This will be acted in the system like this. But in order to represent this temperature also a input, now two inputs are acting here. So that is the reason here I am connecting one summing point. Then this resultant, it will be acted in the processor plant. Now you here in this example, you see disturbance 1 means the disturbance may be at the input terminals, or the disturbance may be in the process unit, or sometimes the disturbance may be at the output terminals. So the disturbance may be at any point. It means which is unwanted to us, those can be called as a disturbances. Here in this one, the disturbance is appearing at the input terminals or in the system, and one more disturbance, sometimes it may act at the output terminals. So these are the various prones of disturbances acting on the system. All these disturbances along with the input will influence the output. So this is nothing but, of course, we can call them as a control variable, but it is not a desired variable. So desired variable might be different from this output or control variable. Now I am not saying that always this desired variable is different from the control variable. Both may be same, may not be same. Now I don't know exactly, because there is no corrective action. This disturbance 2 or disturbance 1 may also influence the output. So in such cases, desired performance may be attained at the output terminals, or sometimes may not be attained at the output terminals. This is about the open loop control systems. And coming to the closed loop control system, the output signal of a closed loop control system is fed back to influence the control action and improve the overall system performance. The example are robo-arms, velocity control systems, and temperature control systems. But now, generally, practically, what type of systems we can come across? Now, the systems are nothing but both are combination with open loop control systems and closed loop control systems. The combination can be used. Now, for example, the best example is if you take a washing machine. Now, automatic washing machine, if you could see the process of filling the water. Now, if you have experience, you kindly observe what is the mechanism and how this washing machine will be function. Now, filling the water, how much it is required, it depends on the how many kgs of cloths you have inserted, you have kept in the washing machine. So, based on that kgs, the machine is going to going to open its water valve, and it will admit some of the water into it. Then this action is nothing but automatic. So that is nothing but it comes under a closed loop control system. And the process of washing and rinsing, it is independent of any feedback loops. So the washing and rinsing is nothing but it is a open loop control system operation. So the washing machine is the best example for the combination of open loop control systems and the closed loop control systems. Now, the same thing here. This bottom one is nothing but output transducer or a sensor. It is now, the sensor is nothing but, this is just now also I told you that it measures the water level indicator. If sufficient water level indicator in the washing machine is going to attain, then automatically it will simply opens it. So this feedback is nothing but, this will be there in the closed loop control system. Otherwise it becomes open loop control systems only. Now these are the few more examples for open loop systems and closed loop systems. And this right side, this robo-arm and ACs are nothing but the closed loop control systems. And because after sometimes in the AC what happens, once the room temperature is as per our expectation, suppose if you could adjust at 23 degrees centigrade or 22 degrees centigrade, once it is achieved, then automatically the compressor will be turned off. So that is nothing but automatically there will be a sensor. It is going to measure the temperature of that particular room. That is going to happen. So these are robo-arm, and these two, that combination of R, that is AC, is nothing but it is the best example for closed loop control system. And anyhow, I told you just now already, this washing machine is nothing but is a combination of open loop control system and closed loop control system. And another one is nothing but these are Xerox machines and some food related items. Those are nothing but the open loop control systems. Now, advantages and disadvantages. Open loop control system is simple in construction. Just now also we have discussed, and those are less expensive corresponding to the closed loop control system. And there is no stability issues at all, open loop control systems. And this is convenient when the output is hard to measure, or measuring the output preciously is economically not feasible. So as per the economic point of view, it is not possible, but it is very easy to measure the output. So because it will be constant, only once the input is acted along with the disturbances, the output remains same. So it is very easy to measure. Now these are the few advantages. And what are the disadvantages of this open loop control systems means the system response is very sensitive to external disturbances, because external disturbances we don't have any control over there, and all these external disturbances will influence the outputs. That is a major disadvantage you can see in the open loop control systems. And recalibration is necessary for time to time in order to maintain the required quality in the output, because calibration is very essential, because output we don't know how far it will deviate from the desired value also. If it is far away, if it is moving completely away from the desired value, so we require some calibration. So anyhow, the system itself, it will be calibrated in the beginning self, but anyhow recalibration is required based on the severity of the disturbances and how effectively the system is prone to the disturbances. Those things will influence, and based on that recalibration is needed badly in the open loop control system. These are the merits and demerits of the open loop control system. And coming back to the closed loop control system, these are insensitive to external disturbances. Of course, now this disturbance is nothing but it is also one type of input. The net effective change, it will be observed at the output, because unnecessary disturbance is there means now we can say that output is nothing but it will be completely deviated from the desired output. So in such case, how much of deviation it will be ensured with the help of feedback, and the resultant will be the net resultant input for the controller, so such that the deviation has been converted into the input signal with the help of feedback. So that is the case. The closed loop control systems could be say that insensitive to external disturbances and possible to use relatively inaccurate and inexpensive components to obtain the accurate control of a given plant. So relatively, if you could see, open loop control systems are cheap and closed loop control systems are nothing but little bit expensive, and better control over transient and steady state responses, and increased accuracy will also increase. Definitely there is no issues at all. Increased ability to reproduce output with varied input. Even the input varies also. Now we can see the output, and ability of producing the output will also increase. Ability of increasing the output in the sense, now the accuracy of the output will be enhanced. And what are the disadvantages? Now instability you can see, and complexity of the system is also increases, and construction of this system is nothing but little bit expensive. So these are the merits and demerits of closed loop control systems, and examples already so many times we have discussed the merit examples of open loop and closed loop control systems. And this temperature sensor, if you could see that input is nothing but the temperature, output is nothing but the voltage. So that is, it may be in millivolts or volts based on the temperature signal. So temperature sensor is also a open loop control system, because it is taking a temperature as input. Now output is nothing but the voltage. Similarly, if you could take amplifier is also, because in this slide I am going to present different open loop control systems along with the inputs and the outputs. So here the input is nothing but V input is the voltage, output is also a voltage. And next one is a DC motor. If you could take now armature voltage, how much of voltage you are applying across the armature, it will be a input, and output is nothing but once the voltage is applied, it will revolve with different speeds. So output is nothing but the speed. Next one is, it is a control valve. Now you can come across in hydraulic systems various controlling valves. Now how much of percentage of open, it will influence the liquid flow. Suppose if the top is completely tightened, so you cannot see any liquid coming out of that particular tap. So this is nothing but the controlling valves. So next one is the level transmitter. Level transmitter, it is nothing but it is a device which converts some level to the current, or some flow of energy. So lift or level is nothing but it will be converted to the current. And next one is control valve only, but it is the combination of, this will be used in the electrical systems to control some of the electrical parameters. So error correction devices also, we can say this as a error. If it is given to a error correction device, now there will be a correction. So these are the various examples you can see for the open loop systems. Here open loop system might have taken electrical as input and it is going to give mechanical output, or sometimes mechanical input can be converted to the electrical output, whatever it may be the nature of the input and output. But in the plant is nothing but it may be divided into different subsections. The subsections might be the subparameters might be the transducers and controllers and actual plant or process and various dynamic systems, whatever it may be. But for the simplified manner, we have represented as a temperature sensor. Temperature sensor means it might not be only one device. It may be combination of various transducers and signal capturing devices and controlling devices and the plant. So like that. So you can take any one of all these 6 we have represented in this. Now it is not a single device. It may be the combination of various sub-blocks. The sub-blocks may be different nature. So these are the best example for open loop systems. And in the previous discussion, we have discussed about the various closed loop control systems. So I hope with this introduction, you learned about open loop systems and what are the merits, demerits, and closed loop control systems and what are the merits and demerits. And we have presented this with suitable examples in this video session. Thank you for watching this video. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.